Okay, here we're looking at a summary of reactions of alcohols. So I've picked an alcohol here that you wouldn't have seen this before. I was making one up. That's the kind of thing they do in the exam paper. They're not going to just pick it. It's not always going to be like ethanol and ethanoic acid. It's going to be more trickier examples than that. This has two OH groups, so it's got two alcohol groups on it. This one here is primary because the carbon, the OH is only attached to one other carbon. This one is secondary because that carbon is attached to two carbons. So whenever you see an example like this, work out their primary, secondary, tertiary because it's very important. Okay, so if we reflux it with potassium dichromate, they're both going to be, both the alcohol groups are going to be as oxidised as far as they can go because it's reflux conditions. So the primary alcohol will go to a carboxylic acid and the secondary alcohol will go to a ketone. I'm just looking at the organic products here, I'm not putting things like waters and things like that, I'm just looking at the organic product each time. Okay, so if though we distill it with potassium dichromate, instead of getting the carboxylic acid, we get the aldehyde. Okay? Be careful when you draw the carboxylic acid and the aldehydes that you still got the same number of carbons. Coming off this ring is 2 carbons. 1, 2, 1, 2. Okay? A common mistake is just is to have too many carbons, to slip an extra one in there or you lose one. So always check your number of carbons, that stays the same. So we distill it, we still get a ketone because it doesn't make any difference to secondary alcohol if it's distilled or refluxed. With potassium dichromate and sulfuric acid, it will make a ketone. This will make an aldehyde. Right, so whenever you see those, you've got to be thinking about oxidation, the potassium dichromate. Whenever you see concentrated sulfuric acid, or in this case concentrated phosphoric acid with heat, you've got to be thinking dehydration. Okay, so now we're removing the OH. And we're going to make alkenes. Now the primary one, if you remove that OH from there and the hydrogen from the neighbouring carbon, you get a double bond and that's the only result you can get. But here, this OH, when it leaves, you could take the hydrogen from this carbon with it, or the hydrogen that will also be on that carbon with it. So the double bond could either be there or there. So if you had taken that hydrogen from here, the double bond would have been there. If you take that hydrogen from there, it would have been here. So two possible products here. Whenever you see any carboxylic acid being added to the alcohol, you've got to be thinking ester. And both secondary, primary and tertiary alcohols can make esters, so that doesn't make any difference. So both groups, if there's enough carboxylic acid, in this case ethanoic acid, they will both make esters. So I'm taking the hydrogens off the OHs, I'm taking the OH off the carboxylic acid, and I'm joining them up to make those two ester functional groups.